Hello coders, welcome to my channel Radhe Radhe. Today is the lecture number 4 of the two pointer, and in this lecture we will discuss two questions related to two pointer. Both the question you will find in the late code. The both the question is the easy one. From the next lecture I will start taking the questions from the medium level. For today, let's see two questions that are of easy level. Now the first question that we have is the uh, square of the shorted array. So let's study what the question is saying. We have given an we have given an array nums sorted in non decreasing order. We have to return the array of the square of the each number sorted in the non decreasing order. It simply means that is saying we have given a nums array. We have to square all the elements and then arrange all the element in the ascending order. If we square 0, it gives 0, 1, 1, 3 is 9, 4 is 16, and 110 in 100. So in this way all are squared and giving the answer. Same way this is also doing the same thing. Now if we see that our constraint is not too much high, you can simply use the for loop to solve this question. So first, as we know, first we start with the brute force approach. So the brute force approach is nothing so much tricky one. It's just simple. Like as we all know, the simple thing we can do is just we take the just we square all the numbers and then we store that number in the another vector and sorted that vector. Like we what we have given is simple question, simple I will square all this thing and 16 will be first element, like what I'm saying. Like if we square minus 4 it gives 16, if we square 1 it gives 1, 0, 9 we have 0 to 0 will square 0, 9 3 will square and gives 9, and then we square we will gives 100, 10 will square is 100. Now we will store this in some another vector and then we just use the sorting algorithm. We will sort it and we will get our required answer. So this is a simple approach. Now if we see what is the time complexity of this algorithm, it's just simple. We are using one for loop. It will take O of n uh, 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 this is for storing all the numbers in the vector, and then we have sorting algorithm that will take O of n log n. So we know that n log n will dominate that factor, so we have got the time complexity as O of n log n. Now if we see the time as space complexity, so we are using one vector, that is one vector, so it will take O of n as a space complexity. So now as this is not a efficient solution, as we all know. So we will have to see for the optimized one. So for optimization we will use the um, two pointer approach. So now if we see the optimized solution, we will use two pointer. If we so let's see how it will work. We have given the array minus 4, um, minus 4, minus 1, 0, 3, 10, minus 1, 0, 3, and 10. So as we know in the previous lecture what we are doing, we are just I'm just making a relation between the question that we have done and in this question. So we know that we putting the two pointers, one from the front side and one from the back side. The same thing we will do here. We will take I as here, j will be here. Now we will as we know that if we square something, we don't care about its minus sign, because like what I'm saying that if we minus 4 it will gives, if we square minus 4 it will give 16, and same way if we square 4 it will also say, gives us 16. So we don't care about the sign. So what we will do, we will check that if 4, ignoring the sign, if 4 is greater than 10, we are just ignoring a time sign, okay? So if 4 is greater than 10, so it is not possible. 4 is not greater than 10, 10 is greater than 4. That is, if that will go into the else condition. So it means if 4 is not greater than 10, so it will go into the else condition. And in else condition, what we will do, we will put that element in that, we will again take any vector to store the answer. We will put that element which is greater in both the answer will be from the back side, because we have to short it into the ascending order. So bigger one will be in the last side. So we see that 4 is smaller and 10 is greater. The 10 is greater, then we put the 10, not 10, the square of 10, because we have said to put the we have to set to make the area of the square. So if we, so 10 is greater, then we will square it and put 100 here. Now again, now, what we will do? We will move the J pointer, because we already completed this. So we will move the J pointer in the left side, as we are doing earlier also, J minus minus. Now we'll check I and J. Which one is greater? 4 is greater. So we will put 4 from the back side here, that is 16. Then we move I pointer. Now we will check which one is greater. 3 is greater. So we will put 9 here. Now we will move J pointer in the left side, no, J minus minus. Now we check which one is greater. 1 is greater. We are just ignoring the sign, as I said earlier. So 1 is greater. 1 into 1 is gives 1. Now if we check 0 is greater. J will be here. Now we check which one is greater. Both are the same. So in this condition, 0 will print in the first side. And if the loop go beyond that I, then it will be the breaking condition. So in this way we will get 0 1 9 1600 as our shorted answer. And as our answer, as you can see, the same thing is there given in our test case. So now if we talk about the time complexity, so you can see we are putting I here, J here, and I will going here, J is going here. So we are using one loop, one while loop. So one while loop take off n time, of n time it will take. And if we talk about space complexity simply we are storing our answer in the this array. So it will also become O of n. So here we can see that we reduce the time complexity. Space complexity we are not able to reduce uh, through the two pointer. So yeah, it's efficient one, because time by complexity is not too much higher, and you can see that we have given only O of 10, 10 to the power 4. So it will pass all our test cases. Okay. If we see the solution, if we see its code, so first we start with the brute force approach code. Now in the brute force approach, like we have taken one for loop and one vector, as I said in my dry run. And then I put all the numbers of this by doing square, then I'll sort it and then return it. In the simple way, this is so simple code. Now the two pointer, what I have done, as I said, we take two pointer left and right. Left it point the first from the first, and right it from point from the last. Now we have the second point, uh, vector. We have vector that we have, from where we will put the answer in that vector. And I taken an L which are pointed from the last side, because it will indicate the index of the answer. Like here, what I'm here, you can see that I'm putting from the 100 from the back side. So L will point this one. Then if this will be filled, then L will move ahead, move backward. We will do L minus minus. In this way, all the numbers will be filled. Uh, so yeah, simple thing. So yeah. So after that, we are taking a while loop. Left is smaller than equals to r. If r will become smaller than left, then it will break out the loop. Now, if we are checking if condition, if left is greater than right, means this one is greater than this one. If yes, so we will put the answer. We will put that answer, that square of that number from the back side of the answer array, or we will simply move the L minus minus, that is this one. We will move the index of this one, L minus minus, or we will simply we will simply use left L plus plus, because this is already put in uh, our vector. So after that, we have if this condition is not satisfied, then we will go to the else condition, and in the else condition, if the right is greater, then it's the same thing. The same code I have written here. So only the difference is that here we are doing left plus plus, here we will do the right minus minus, like we will move the right pointer, j pointer we will move here, because this is already put it in our sorted array. So in this way we will solve the question, and we will return the answer. So yeah, a simple approach of two pointer. Now the second question that we have is move zero. It is again a easy one question. In this question, we have given an integer array nums. We have to move all the zeros to end of it while maintaining the relative order of the non-zero element. Now, what the question is saying is that we have to put all the zeros to the left, to the back side, and but 1 3 12 can't not be or means maintain the order. It will not like that 3 will go 1 will go 3 will go ahead, not like that. We have to maintain the order. 1 3 12, 1 comes, 1 comes, then 3 comes, then 12 comes, and all the zeros is in the last side, last two from means in the back side. So yeah, this question is simple. And so now the brute force approach that we all are we are thinking that is a, it's coming to everyone mind, that we will just what we will do, we will take of another vector, and we will put all the element which are we will run a loop and check if the number is not equals to 0, then we'll put the number here. Like here in the case we have 132. We will move the pointer, first pointer will point 0. If it is 0, then we will move ahead without doing anything. Then it one comes 1. 1 it comes any number that is greater than 0, and that is not equals to 0, then we put into the number in our vector. Then we will again see 0 is coming, so we will not do anything. 3 comes, then we will put 3 here. Then 12 comes, then we put 12 here. Now how many numbers are left? We will see the size of the size of the array, original array, and minus the size of the current array. Like here 3 numbers are filled, so 2 will become 2 is left, so here in the 2 we will put 0 0 only. So in the simple way we will solve that. Now we will see the time complexity that will take in with nothing, just O of n. Time complexity will be O of n, and space complexity is O of n again, because we are taking one vector to store uh, our number, so it will O of n. So time complexity while it is good, but is there any another way that such that we can reduce the space complexity? So yeah, we have one of the two pointer approach that we will use to solve this question. What we will do, we will just take the simply will take the number, we will take the number 0 1 0 1 0 3 12. Now what we will do, we will just take I in this question. There is no some there's not like sorted or unsorted, so we will not take I in the first side, j in the second side. They will taken when we need to compare something, but there in this case it's not like that. We will take I here and put the j again here, and we check that if the I or j, if we will move j pointer, not I pointer. If we check if the nums j is 0, so what we will do, we will move the j ahead, and then we'll check if the again check if the nums j is not 0. If not, here 1. So what we'll do, we will just put the I in the in the place of nums I. put the nums in the place of nums I. Like 0 will be removed and I will be come here. Same way, if again we move the j, here 0 is given. 0 is given, we will not do anything. We will just again move the j pointer. 3 comes, so we will place the 3 in the nums I position, that is here. So here will be 3, we will get 3. Again 13 comes, we will nums I will be here. 13 comes, 13 will be go here, and the last two will be put by the zeros. So in this way, there is no need to take another vector. So the same thing I have doing here. We'll take I, j, and then nums I, and I'm checking because j is moving ahead now. That's why I'm checking j not exceed the size of the nums, and check that if nums j is not equal to 0, putting number, that current number, into the in from the into the first number, like nums is pointing the previous number, and then I'm doing I plus plus j plus plus, and from the rest 0, we're checking I smaller than n, because I is taking care about the how many columns are left that are not filled, and that they are not filled, that it obviously it will be filled with 0. So I'm just putting nums I equals to 0 and doing I plus plus. So in this way, we reduce the space complexity, and here we see that the space, there is no space, so we are just taking it will taking only O of 1 as a space complexity. So in this way, we not only reduce the time complexity, we can also reduce the space complexity by using two pointer approach. So yeah, that's it. That's it. That is a two question that in the today's lecture I have to discuss. And if you like my video, please like, share, and subscribe. And thank you.